Good day. This is Bennett, also known as Jeremiah. Today we're going to deal with questions on future value and present value in financial mathematics. If you're interested in more videos, the playlist is found at the end of this video. It is also found right here on the top right of the screen at the suggested video. So, let's begin.
Whenever you are doing financial mathematics, whenever you are doing either present or future value, you should always use the 3-point check. So I'm going to explain this when we do a practical example. So this will ensure that you apply whatever is necessary and you don't miss your marks. Alright, here's the first scenario. So they said suppose that Precious invests 500 every month for a period of 8 months, starting 1 month from now. Her interest is 9% per annum compounded monthly. Calculate the value of her investment at the end of 8 months after she has made the 8th payment. So before we talk about the 3-point check, it is very important to know what is the difference between future value and present value. So future value is when you are saving for the future, when you want to have that large amount of money in the future. Maybe you want to have 3 million in the future. Whenever you want to have that large amount of money in the future, this is future value. But whenever you borrow money, or let's say you get a loan, so you have that large sum of money now. So whenever you are dealing with loans or mortgage, this is present value because you are given that large amount of money now. You just have to pay it back. So mortgage is when you're given a loan so that you can buy a house, then you pay it back over time. Therefore, when it comes to mortgage, you have the money now, so it's present value. But whenever you are saving for the future, you are going to have that money in the future, so that is future value. So notice that they said suppose that Precious invests 500 every month for a period of 8 months, starting 1 month from now. Her interest is 9% per annum compounded monthly. Now they said calculate the value of her investment at the end of 8 months. So that large amount of money, she will have it in the future. So she is saving so that she can have a large amount of money in the future. So future value, we're going to have that large amount of money in the future. Present value, we have that large amount of money now, hence it's called present value. Alright, so let me explain and use the 3-point check. So the first thing you have to check is that is the first payment made 1 period later. So what you have to understand is that in financial maths, it is normal for the first payment to be made 1 period later. For instance, if somebody decides to be paying monthly, then it is normal for the first payment to start 1 month from now. Or sometimes they can say at the end of the month, which is the same as 1 month from now. Sometimes they can say after 30 days, which is still the same as them saying 1 month from now. So this is normal. If the person decides to be paying instead, let's say quarterly, then it is normal for the first payment to start 3 months from now. Or if you want, they can say at the end of 3 months. If the person decides to be instead paying half yearly, then it is normal for the first payment to start 6 months from now. Or if you want, at the end of 6 months. If the person instead decides to be paying every year, then it is normal for the first payment to begin 1 year from now, or if you want, at the end of the first year. So that is the first point. It is always important to check if it is made 1 period later. So if the payment is not made 1 month later, then there are manipulations that we have to make. So this is why I created a playlist. All the videos of the playlist will be based on these 3 principles, whether it is future value or present value. So this is what we're going to use for everything. So is the payment made 1 period later? So in this case, because it's monthly, is the payment made 1 month later? So they said Precious invest 500 every month for a period of 8 months, starting 1 month from now. So it's normal. So if it was not normal, there are manipulations that we're going to make. And then the next thing to check is that is the final payment made at the end of the total period. So let's check it out. So now notice that they said she invests 500 every month for a period of 8 months. And they ask you to calculate the investment at the end of 8 months. So the last payment is the same as the total period. Because she makes payments for 8 months, and we want to find out how much will she have at the end of 8 months. And the last thing to check, this one is very critical. It's easily missed by a lot of students. This is why in past papers they also get it wrong. So you have to check if the interest rate is the same as the frequent time of payment. What do I mean? If the person is paying monthly, so in this case, notice that the person is paying monthly. The interest must also be monthly. So if the person is paying monthly and the interest rate is semi-annually, we have to convert the interest rate from semi-annually to monthly. So memorize this. This is gonna be very important. The 3-point check, you will always use it whenever you are doing future value or present value. Is the payment made one period later? Is the final payment made at the total period? Is the interest rate same as the frequent time of payment? So here when we use the 3-point check, the payment starts 1 month from now, so it's normal, no manipulations needed. And the final payment is also made at the end of the period. And lastly, the interest rate is the same as the frequent payment. So meaning that the formula, there is nothing special to apply. So we've already agreed that this is future value because the person is saving money for the future. The person wants to have that large money in the future. So future value is equals to the frequent payment. So X stands for the frequent payment. And then we've got in brackets 1 plus I to the power of n minus 1. So this is all, it's going to be all over I. So sometimes the formula is presented this way, sometimes the formula is written like this, sometimes it's written like this. So do not worry about their format, they're both the same. So these two formulas are exactly the same, they're just written differently. So let's apply the knowledge. So N stands for the number of payments, and I, of course, stands for the interest rate. So now the frequent payment is 500, right? So X stands for the frequent payment, right? Either the frequent deposit or the frequent withdrawal. So the frequent payment is 500, right? That's the frequent deposit. So then we're going to say 1 plus. So now the interest rate is 9% per annum compounded monthly. So we do it just like in grade 11. So it's going to be 0.09 divided by 12 because it's monthly. And the number of payments, notice that there will be 8 payments, right? Because this is just 8 months. So it's just going to be 8 payments. If it was monthly for 5 years, then the number of payments would have been 5 times 12, which would have been 60 payments. So N stands for strictly the number of payments. You can look at it as the number of years, but it is the number of payments. So that's how it is when it comes to present and future value. So then this is going to be minus 1, then we're going to have over 0.09 over 12. So you must notice that this will always repeat because we've got I and I. So all we have to do is to plug in this in the calculator and find out the future value. So that amount will be 4106.59. So this is the future value that the person will have, right? The person is not going to have this amount of money now. The person is going to have it in the future. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement. Alright, here is another question. So you are told that Mr. Klein opens a savings account for his son's future education. He makes his monthly payment of $850 at the end of each month for a period of 10 years, starting immediately. The interest rate is 12.3% per annum compounded semi-annually. Calculate the value of his investment after 10 years. So, we have to use the 3-point check. But before we use 3-point check, Let's find out, is this an annuity situation? So we have to find out, is this an annuity situation? Yes, it is an annuity situation because he makes monthly payments of 850. So it's a consistent amount for the fixed period, right? So a constant amount for the same period of time. And is it future or present? It is future. Notice that they said he opens a savings account for his son's future education. So he wants to have that large sum of money in the future. So it is future value. So let's use the 3-point check. So we have to find out, is the first payment made one period later? So notice that he's paying monthly, right? He's paying monthly. Now when does he start? He starts immediately. So it's not at the end of the month or 1 month later. If they say at the end of the month, it's the same as 1 month later. So he makes his first payment immediately. What you have to understand about payments being done immediately is that there is gonna be one extra payment because payment is supposed to start 1 month later. So because it started immediately, it means there's gonna be one extra payment. So you calculate the number of payments as usual, but you add 1. So this appears a lot in past papers as well. If he pays immediately, there is 1 extra payment. So now we know it's going to be number of payments plus 1. Now we have to also check, is the final payment made at the end of the total period? So when does he make his final payment? He makes a monthly payment of 850 at the end of each month for a period of 10 years, right? Starting immediately. And notice the question says calculate the value of his investment after 10 years. So it's still the same. And then the last one, which is very important, this one can really affect the calculation. Is the interest rate the same as the frequent time of payment? So notice the payment is monthly, right? So he makes monthly payments of 850. So the payment is monthly. And notice something about the interest rate. The interest rate is 12.3% per annum compounded semi-annually. So the payment is monthly, yet the interest rate is semi-annually. So we have to convert it from semi-annually, which is also known as I2, into monthly, which is known as I12. So you should understand these symbols because they can actually ask you indirectly. They can ask you to show that I12 is a certain amount. So if they ask for I12, you have to know that they're asking for monthly. So these numbers actually represent the number of payments per year. So it is not an exponent, it's just the number of payments per year. So if you see something like I4, then we know it is quarterly because it's 4 times a year. If you see something like I52, then it is weekly because there are 52 weeks in the year. But we've never seen this so far. So make sure you understand that. So I2 just means semi-annually, I12 just means monthly. So we have to convert it from semi-annually to monthly. So how do we do it? So we use this formula. It's very important. It might not be at the formula sheet. So you have to be aware that we use this formula. So this is going to be IM over M, and this is going to be... So remember, this is not an exponent. It just tells you how often is the interest rate compounded. So you'll say it's equals to 1 plus IN over N, and then to the power of N. So the order doesn't matter. Even if you started with N here and N and M here, it really doesn't matter. So far, we're trying to convert it from semi-annually to monthly. So the interest rate is 12.3%. So you're going to say 1 plus 0.123, right? Because it's 12.3%, so 0.123. Then this is going to be divided by 2 because it's semi-annually. And then we're going to say times 2. So notice something. The number of years are 10. However, I did not include it in this formula because whenever you are using this formula, you do not include the number of years. This M, right, and this N strictly stands for the number of times per year. So you only consider the number of times it's compounded per year. You don't include the number of years. So here, because it's semi-annually, we just put 2 and 2. So we want to convert it into a monthly rate. So we're going to say I12, right? Remember, it's not an exponent. It just means the interest component monthly. And then we divide by 12 and we multiply by 12, right? Monthly, right? So that's how it is. So now we have to solve for I12. So let's solve for I12. So now this is gonna be 1 plus 0.123 over 2. So okay, so over 2. Then this is gonna be to the power of 2. So now in order for us to make this the subject, the first thing we have to get rid of is this exponent. So how do we get rid of the exponent? We get rid of it by making it 12 root on both sides, right? Just like if you had a square, you would get rid of it, right? If you had x squared is equals to 25, you would get rid of this square by square rooting, right? So that's what you do. So if you have to the power of 12, you get rid of it by using the opposite root. So since we had 12 here, we 12 root it so that we can get rid of the square root. So it means it's gonna now be 12 root here. So then this is gonna be 1 plus I12. So I12 over 12. So now I have to take the 1 to the other side of the equation. So let's do that. So now this is gonna be, so it's gonna be 1 plus 0.123 over 2. And then I'm gonna have minus 1. So now I'm gonna be left with I12. So I12 over 12. So what is left for this to become the subject of the formula is that we have to get rid of this denominator. So notice that whenever you've got something like x over 2 is equals to 10, what you will do is that you just simply say 10 over 1 and you will just cross multiply, right? So you would literally say x times 1, which is x, and 2 times 10, which is 20. So you also do the same thing here. You can solve it anyhow. I'm just using one method. So you can say this is over 1, right? Then you just simply cross multiply. So it just means that this 12 is going to multiply this stuff. So let me get straight to the point. So it's going to be 12 root. So this is going to be 12 times 12 root of 1 plus 0.123. So this is all squared. So over 2 and then minus 1. So this is what we have. So now we're going to have I12. So let's check what the calculator gives us. So your answer will be 0.11, so 11,996,1654. So please do not round off yet. Please do not round off until you have multiplied it by 100. So whenever you are calculating for interest, whenever you are finding interest in any situation, do not round off until you have multiplied it by 100. So notice that we first divided it by 100, right? We divided the interest by 100. So I want you to notice that we divided it by 100, right? So before we plug in the interest here, we divided it by 100 because it was 12.3%. We actually got 0.123 because we divided it by 100. So when you are finding the interest, right, when you are finding the other interest, this one that is missing, so whenever you are finding the interest in any situation, you have to multiply it by 100. So when you multiply by 100, you get 11.9961654. This is when you round off. So we'll have I12. Now notice that when we round off this to two decimal places, it actually gives us 12. Literally gives us 12 because this 6 will cause this to become a 10, which will shift here and shift here. So the final answer is actually 12. So 12% per annum compounded monthly. So we have found I12. So that was the 3-point check, right? So we discovered that it was not made 1 month later, 1 period later. So we had to send number of payments plus 1. And then here the final payment was the same as the total period, right? Because it was what? It was a period of 10 years, right? And they asked us to calculate the investment after 10 years. And then finally we discovered that the interest rate was not the same as the frequent time payment this time. So we had to convert it from semi-annually to monthly. So now we know that the interest rate per month, so the monthly interest rate is gonna be 12%. So the monthly interest rate, right? So the interest rate compounded monthly is gonna be 12%. So we know that it's future, right? Because the saving is saving for his son's future education. So now we're gonna use the future value. So future value, we're gonna have x. So we're gonna have x, then we're gonna have 1 plus I to the power of n minus 1. and then close the bracket, and then all over I. So the monthly payment, right? The frequent payment. What is the frequent payment here? In this case, is the monthly payment, which is 850. So the frequent payment is 850. So 850, and then from here we've got 1 plus. Now the interest rate is the one that we calculated, right? The monthly interest rate, since the guy is paying per month, so it's not gonna be 0.123 because 0.123 is the compounded semi-annually, right? But we wanted monthly. It must be the same as the frequent payment. So this divided by 12, then this is gonna be the number of years. The number of years is 10 years, so it's gonna be 10 times 12. Now notice that this is the total payment for 10 years. However, payment was done immediately, right? Payment was done immediately. So that payment that is done immediately is an extra payment. So it means it's gonna be number of payments plus 1. So we're gonna add 1. So that's what we have. So now we always know that the denominator is always gonna copy that, right? So it has to duplicate. So this is what we have. So this has to be the same as this. And all we have to do is to plug in this in the calculator and we'll have our answer. So the answer should be 198,338.21. You can verify with me. So always remember this. This is a past paper question. Whenever payment is made immediately, it's number of payments plus 1. Alright, here is the final scenario of the lesson. Just before you attempt this example, if you're interested in knowing the prices of the tutorials, the video that contains the prices and the updated contact details just in case these ones have changed is found at the end of this video. So they said Precious takes out a mortgage bond of 760,000 on a house. She pays 120,000 as a deposit. If she settles the mortgage bond over 20 years and the interest is calculated at 15% per annum compounded quarterly, how much will Precious pay each month if the monthly payments start in 1 month's time? So we have to figure out, is this future or is this present? So whenever somebody saves for the future, we know it's future value. Whenever somebody borrows, right? Whenever somebody takes out a loan or a mortgage bond, it is present, because notice that they have the money now. They are given the money now, hence they're able to buy the house, they're able to purchase the house, and then they pay it back over time. So this is going to be present because the person has the money now. Then we have to use the 3-point check. So the first point of the 3-point check is that we have to check if the payment is done in 1 period's time. So is it done in 1 period of time? So she's making monthly payment and she's going to start in 1 month's time. So it eventually looks like it fulfills the first point of the 3-point check. But we've got a slight problem. She paid a deposit even before this payment started. So this situation of deposit appears a lot in past papers. So what you should do every time you are given that somebody takes out a loan and pays a certain deposit, notice that if somebody takes a loan and pays a deposit immediately, then the loan is reduced immediately. So what you have to do is to subtract this from the total loan. So you will just say 760,000. So you're just gonna say 760,000 minus 120,000. So the loan is now going to be 640,000 because notice it has reduced. Whenever somebody borrows and then pays a deposit, then the loan reduces. So this is gonna be a new present value. The second thing to check is if the last payment is the same as the total duration of the agreement. So notice that they said if she settles the mortgage bond over 20 years, meaning that she will take 20 years to finish it. So it means that her last payment will be on the 20th year. So the last thing to check is if the interest rate is compounded the same as the frequent payment. So notice that they said 15% compounded quarterly. So the interest rate is compounded quarterly while she's making monthly payments. So we can see that the interest rate is not compounded the same as the monthly payment. So it does not fulfill the third part of the 3-point check. So we know that we have to use this formula. So we're going to say 1 plus I. So there's going to be I, then there's going to be IM, right? so which is not an exponent, it's just a symbol. So this particular m is just a symbol to show how often it's compounded. So then there's gonna be m, and then we're gonna have 1, then there's gonna be plus I, then there's gonna be n, then all over n. So now we want to convert it from quarterly to monthly. So then there's gonna be, so it's gonna be 1 plus, it's gonna be 1 plus, so the interest rate is 15%, right? So when I convert it from a quarterly rate of 15%, so it's gonna be over 4 because it's quarterly, and then this is gonna be equals to 1 plus, so it's gonna be 1 plus, and then now we want to convert it into a monthly rate, so hence it's gonna be I12, and then here it's gonna be 12 because this particular portion is monthly, so we want to convert it from quarterly to monthly. So I leave it for you to solve. So you have to solve for I12. So when you solve for I12, your final answer should be 14.82. So just confirm with me. So this is what we'll use. So we agreed that it's present. So we're going to say present value is equals to the frequent payment. And then we're going to say 1 minus 1 plus I to the power of negative n, since this is present. So then this is going to be I. So the present value, which is the new loan, right after subtraction. So this is going to be 640,000. Then this is going to be equals to, so the frequent payment is what we're looking for, right? Because they said how much will Precious pay each month, right? So how much will Precious pay each month? So that's what we're looking for. So then we're going to say 1. So we're going to say 1 minus, then it's going to be 1 plus. So now the percentage which we got, right, which we calculated, the monthly rate is 14.82. So it's going to be 0.1482. Now we're going to say divided by 12 because it's monthly. Then there's going to be, so the number of payments. Notice that the payments, right, because it's 20 years and it's monthly. So we're going to say 20 times 12. So this is going to be equals to negative, this is going to be 240, right, because this is negative. So it's going to be negative 240. So this is what we have. So then we're going to say divided by, so this is going to be 0.1482. So this is going to be divided by 12. So remember, it should duplicate, it should be the same. So now we have to solve for x. So every time you're solving for x, my advice is to multiply these two first, so that you're going to have 640,000, right? Then you're going to have times 0.1482 over 12. So this is what we'll have when you multiply these two stuff, right? So this is how we get rid of this denominator. So then we're going to have x, then this is going to be 1 minus, so this is going to be 1 plus. So we're going to have 1 plus 0.1482. So this is over 12. And then this is going to be to the power of negative 240. So that's what we're left with. And then now, in order for x to be a subject or a formula, we have to get rid of this. And since they're multiplying, we just have to divide both sides. So we're going to divide both sides by this particular portion. So that's what we have. So these two will cancel. So when they cancel, we'll be left with x. So this is how you make x the subject of formula. So you just make x the subject of formula. So whenever you're looking for the frequent payment, this is what you do. So all you do is just to multiply this, then you just divide both sides by this. So this is what we have. So now you type exactly this stuff in the calculator. So you type it exactly as it is in the calculator. So let's get our answer. So what is the monthly payment? So just confirm with me that it's gonna be 8342,46. So there we have it.
Alright, we have reached the end of this video. I have included a playlist of similar type of questions. If you enjoyed this video, please like the video and subscribe to my channel. Any questions you've got or any video you want me to create, please comment below. See you in the next video.